6.3, add, subtract, and multiply polynomials.
Yay. This one seems easy.
These were the ones
The hardest are multiplying, depending on which like form you have.
Do we divide them eventually?
Yes, but I don't remember what section that is.
You're not coming? You're not coming to school?
Find the sum or the difference. X squared minus 3x plus 5, and then minus, all in parentheses, negative 4x squared plus 8x plus 9.
Is this kind of what we did the other day?
Kind of. It's a just slightly more difficult version of it, I guess you could say. I mean, not really that much harder, but I would probably recommend you distribute this negative through here first, because just based on what I did see on the stuff that we did the other day, that seems to be where our issue is with stuff like this. So I would do x squared minus 3x plus 5, and then distributing this through, I would have plus 4x squared minus 8x minus 9. And then combining like terms. So I've got 5x squared minus 11x minus 4. Now, if you can do it by just saying, okay, x squared minus a negative 4x is 5x squared, you're welcome to do that. That's what I normally do, but I'm worried with this sign that you're not going to remember to distribute it to everything, especially if you don't have a term like over here. If one of the terms was missing over here, you wouldn't remember to do minus whatever is over here. So just make sure you're careful with that. 8. 2a squared minus 8 minus, in parentheses, a cubed plus 4a squared minus 12a plus 4. So this is what I was kind of talking about with that. So I have 2 terms in this first thing, but I have 4 terms over here. So if you're not careful, you're going to forget to distribute this negative through to the terms that you're not like directly subtracting, if that makes sense. Or you might leave terms out altogether. So I would distribute this through. So I have 2a squared minus 8 minus a cubed minus 4a squared plus 12a minus 4. And then combining, we've got, because we want them in standard form, negative a cubed. And then I've got negative 2a squared.
Plus 12a minus 12.
Yep, plus 12a minus 12, yeah. $12, 3y squared minus 6y to the 4th plus 5 minus 6y, and then plus 5y to the 4th minus 6y cubed plus 4y.
Whoa.
So this one, obviously I don't need to distribute because this is just plus. So that means the signs just stay as they are. So I would just work through and do my terms in order though, so that I don't have to like rewrite it all again. So negative 6y to the 4th plus 5y to the 4th, negative y to the 4th. And then y cubed, I don't have any in the first one, but I have negative 6y cubed in the second one. Y squared, I don't have any in the second one, but I do have one in the first one, so plus 3y squared. Just y terms, I have one in both, so I have negative 6y plus 4y is negative 2y. And then constant terms, I have one in the first one, but I don't have any in the second one, so just plus 5.
Well, now we're done.
All right, that's adding and subtracting. That's the easy stuff.
Now we're multiplying polynomials. Yeah. Polynomials. I'm just hungry.
16. x times 2x squared minus 5x plus 7. So on this one, obviously I'm just distributing the x to everything. So I have 2x cubed minus 5x squared plus 7x. And that's all I would have to do on that one.
Ooh, I like that one.
We're working ourselves up.
Do I want to cut it?
18 y minus 7 times y plus 6. So these are just the multiplying that we did in the previous chapter where we were foiling things to get them into standard form. So I've got y squared minus 7y plus 6y, so that's minus y, and then negative 7 plus or times 6 is negative 42. So I end up with y squared minus y minus 42.
Oh, that's cute.
So those ones,
I like them.
easy.
I wish we
20 w plus 4 times w squared plus 6w minus 11. So I like to call these like superfoil because it's a little bit more than just like the regular where we have like 2 and 2. But essentially I'm distributing each piece. So like w is being multiplied by each of these 3 things. And then 4 is being multiplied by each of these 3 things. So that's why you'll hear me often say superfoil. Just means distribute it to everything that's in there. And then I'll combine like terms and simplify it down into standard form in a minute. So I've got w cubed plus 6w squared minus 11w. So I've taken care of the w times everything. So now I've got 4 times everything. So I've got plus 4w squared plus 24w minus 44. And then I just need to combine like terms and put them in order. So w cubed plus 10w squared
plus 13w minus 44.
Yep.
Oh, yes.
Yeah, you could ever this is like I work out
Every day. Someone's
24.
Oh.
All right, negative d squared plus 4d plus 3, and then times 3d squared minus 7d plus 6. And that's like 7d, not the number 7d.
So do we just superfoil this?
Yep, so each of the pieces in the first one gets multiplied by each thing in the second one. So I'm going to do the negative d squared times everything, then the 4d times everything, then 3 times everything. This is like a super foil. So I've got negative 3d to the 4th plus 7d cubed minus 6d squared. So that's the first piece. Plus 12d cubed minus 28d squared plus 24d. And then I've got 3 times everything, so that's plus 9d squared minus 21d plus 18.
Whoa.
That's very long, probably.
No joke.
So if you can see the numbers and make sure that you have everything, that's fine. A lot of times with my like terms stuff, I'll go through and put like 3 lines under each of my cube terms or like 2 under each of my squared terms to make sure that I get them all. It's really just up to you if you want to do that or not. Some people find it helpful, some people don't. Again, purely up to you. So 4th terms, I only see one of those, so that's negative 3d to the 4th. Cube terms, I only have 2 of those. So that's going to be plus 19d cubed
34 minus 9, 25.
for d squared.
Yeah.
Yeah.
25.
Minus 25d squared.
And then 3d and 8.
Yep. Plus 3d plus 18.
Whoa.
So obviously it's a lot. Just make sure that you've gotten all of your terms. If you find it helpful to cross them out as you do them so that you know you've gotten everything, you can also do that. Some people find that to be really helpful. I would just ask, don't like scribble them out, because if I need to go back and look at your work, if you scribbled it out, I can't see what you did. So just put like one line through it.
I stack over d squared, negative d squared, and then I go down one.
Yeah, like a normal multiplication problem.
Yeah.
Like one set and you put it at the top.
Yeah, and then you just add them all down as well.
Whatever works for you, as long as you get to the right final answer. I don't really care that much. Just watch your signs with that stuff.
Oh,
Watch your
wow.
signs, Johnny.
All right. Find the product of the binomials. So we're still just multiplying.
I already wrote down 20. Great.
I was debating skipping it, but I decided to go ahead and do it. All right. X plus 4 times x minus 6 times x minus 5.
Okay.
So just a couple things here. It does not matter which two I multiply first. I can't multiply them all at the same time. But what I would say is look if anything is a difference of squares first or a perfect square trinomial, deal with those first. I do not have that situation here, so it really doesn't matter. So I usually just go left to right, so I do these two and then I do these two. If it looks like something's going to be easier, I might do it a different order, but this one really doesn't matter. So I'm going to do FOIL the first two, and then I'm going to multiply it all by the x minus 5. So I've got x squared plus 4x minus 6x, so that's minus 2x, and then minus 24. And then all that times x minus 5. So I'm just going to do in order, I'm just going to do x squared times both of these, negative 2x times both of these, so on and so forth. So I've got x cubed minus 5x squared minus 2x squared plus 10x minus 24x minus 120.
120.
Oh, plus 120. Negative. Wait.
Yeah, it's plus.
Doing it in this order was nice because everything's already in order of the way it needs to be. So x cubed minus 7x squared minus 14x plus 120.
What?
Yankee Doodle up to town.
36. 4x minus 1 times negative 2x minus 7 times negative 5x minus 4. All right, so again, I don't see anything that's like a difference of squares or anything that's going to make it easy, so I'm just going to go left to right. So I've got negative 8x squared minus 28x plus 2x plus 7. So then combine like terms in the middle there. I've got negative 8x squared minus 26x plus 7. And then all that's being multiplied by the negative 5x minus 4. So then multiplying, I've got 40x cubed plus 32x squared. Oh, lovely. 152? No,
32.
What are you trying to do?
the 26x times negative 5x.
It'd be 130.
Yeah, there we go. Thank you.
Because 5 times 25 is 120.
Yeah, I don't know why I went to 150. Then I was like, that's not right. And then I was like, yeah, anyways. Okay. Plus 104x minus 35x minus 28.
Great.
And then yes. I was like, there's too many terms there.
98.
Cookie!
You know, right after you did it, but I didn't say anything.
I was looking at it and I was like, something's not right, but I was trying to figure out where it was, and then he said it, so. All right, so we end up with 40x cubed plus 162x squared plus, what is that, 69x minus 28.
Bad.
All right, the next thing is finding the product with special products. Again, I wouldn't necessarily tell you to use special products to find it on the quiz. I'm just going to say find the product. Generically, it would be your responsibility to recognize the special product. I will tell you, recognizing the special product on the cubed ones is going to be really important, or it's going to take you forever. So, anyways, but 38 x plus 5 times x minus 5. What is this?
This is
Special name.
Perfect. Oh. It is not a perfect square.
Difference of squares.
Difference of squares. Got it, guys.
not what you
Differential
said.
binomial, bro.
So that means it's just the first term squared minus the last term squared, so x squared minus 25.
This is my last page of my notebook.
You almost made it.
That was her.
No, I meant you almost made it through the semester.
Yeah.
You silly.
All right, just a quick review from your notes before we do the special types for the other ones. For the cube of a binomial, no, you have these in your notes, you don't necessarily need to write them again, but I'm writing them here for you. If I have a plus b cubed, this is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So the first term goes in descending order, cubed squared to the first to the 0. The b term goes in order from 0 to 3, so b to the 0, b to the 1, b squared, b cubed, and then it's 1, 3, 3, 1. Okay, this is part of something called Pascal's triangle that hopefully we'll get to later in the year because it'll be helpful going into pre-cal. So we'll at some point refer back to this and you'll probably be like, oh, that makes sense. Okay, if it is a minus b cubed, all the signs of the plus one are plus, but for the minus one, it is a cubed minus 3a squared b plus 3ab squared minus b cubed. So the second and fourth terms are negative if it's minus,
Minus 3a squared b.
because it's a pattern of 1, 3, 3, 1. So Pascal's triangle, let me just show it to you. Again, you don't have to write this right now, but so you can see it. Pascal's triangle looks like this, and then it goes 1, you add these two, and then it's 1 on the end. 1, add these two numbers, 3, add these two numbers, 3, and then a 1 on the end. And then it would keep going on down. Okay, so the cube of a binomial is off of this row, 1, 3, 3, 1. So we have 1, 3, 3, and then a 1 here in front. The perfect square trinomial, that is a squared plus or minus, depending, 2ab plus b squared. Did I write that right?
There's the one above the 1, 3, 3.
Yep, is the 1, 2, 1. 1, 2, 1. Okay, so you don't need to know this triangle thing. I'm just showing it to you. It'll make more sense later in the year when we get into patterns and stuff like that.
One.
That's a single
Just a
number.
1.
Just one. Oh.
It's just one.
Okay.
Whoa.
So, but anyways, cube of a binomial follows this. If you forget this, you can absolutely just superfoil and it'll work and get you the same answer. But I'm going to use the special type because if you can recognize the special type, it'll make your life way easier. So 40, y plus 4 cubed. Okay, so this is A and this is B. Okay? So, a cubed, so I've got y cubed. This is plus, so everything's going to be plus. Plus a squared, so that's y squared, times b, or I forgot the 3. 3 out front. 3a squared times b, so that's 4. I'll go through and multiply stuff through in a minute. Plus 3, a is y, b is now 4, that's squared, that goes there. And then plus the last term, b cubed, so 4 cubed goes there. Okay, so then now this would become y cubed plus 12y squared plus 48, 48y plus 64. So the end doesn't necessarily look like this, right? Because sometimes if there's numbers here rather than variables, obviously they're getting multiplied. But your initial setup would follow this pattern, which is how I've written it here. Okay? But like I said, if you forget the pattern, you can always just do y plus 4 times y plus 4 times y plus 4, and you can do it that way as well. Not so much worried about you getting this correct pattern as I am about you getting the right answer. But 42, 3t minus 4 cubed. So difference here is my a term is 3t. That all goes together. So when I cube it, I'm cubing the whole thing. So I usually just write 3t and then cubed. If you want to go ahead and multiply it out, be my guest. This is minus, so the second sign is minus. 3 times the first term squared, so 3t squared, times the last term, which is 4. Then this term is plus 3 times the first term, 3t, times the last term squared, so 4 squared, and then minus 4 cubed. So we get 27t cubed. Let's see, this is 9 times 3 times 4, so 12 and 9 is 108, so minus 108t squared. Over here I've got 16 times 9, so that's 144. You shouldn't need it. And then minus 64 again. So notice plus, minus on that one. Do we need to see one more of these ones? Or are we good?
I wish I never had to see it for the rest of my life, but
Are we good, or do we want to see another one?
good. We're good.
Okay.
Oh man, can I please pick?
All right. 5,
I'm about
13, 19, 25,
I got it.
31, 39, 41, and 43.